Hey everyone, welcome back to another explainer. Today we're diving into something absolutely foundational. If you've been following the bleeding edge of AI, you might have caught wind of a massive 88-page academic paper recently dropped by DeepSeek and Peking University. It's all about a system called Cortis. Now, the paper itself is super dense, filled with mathematical type theory and deep software architecture. But don't worry, you're not going to have to read a single page of it today. We're going to unpack exactly what Cortis is, how it powers the brand new DeepSeek harness, and why this is literally the missing puzzle piece for creating truly self-evolving AI. Okay, let's dive into this. To really appreciate the solution here, we kind of have to understand the problem first. You can think of modern software engineering a bit like a massive Jenga tower, right? In standard plugin systems, if you want to swap out a single block at the bottom, like unloading a plugin, you basically have to knock the whole tower down and rebuild it. You have to do a full host process restart. But DeepSeek's Cortis introduces a totally fluid solution. We're talking dynamic, hot-swappable plugins at runtime with zero restarts. None. So, here's our roadmap for today's explainer. First, we'll look at the agent restart problem. Then, Cortis, the Lego baseplate. After that, mastering time and space. Then we'll go inside DeepSeek harness. And finally, we'll wrap up with the self-evolving AI era. Section 1, the agent restart problem. To prove this isn't just some obscure edge case issue, the researchers looked at a massive industry standard, Visual Studio Code. VS Code is actually a classic example of a pretty rigid plugin architecture. The paper calls out a wild statistic. As of June 9th, 2026, literally 87 of the top 100 marketplace extensions contain executable code. And the problem with that? Well, once they're activated, they absolutely cannot be independently unloaded while the system is running. If you want to disable one, you're forced to do a complete extension host restart. The plugin goes in fine, but it essentially refuses to come out cleanly without just pulling the whole system down with it.
Now, if you're just a human developer writing code, a quick restart is, it's just mildly annoying. But apply that exact same logic to our current AI trajectory. If we're trying to build a self-evolving AI, an agent that dynamically writes, tests, and loads its own tools on the fly to solve problems, a system restart is a fatal bottleneck. It means a catastrophic loss of memory, context caches, and current state. The AI essentially gives itself a severe case of amnesia every single time it updates its own toolset. And obviously, that completely breaks the dream of true self-evolution.
Section 2, Cortis, the Lego baseplate. To solve this massive headache, they built Cortis. It's a foundational framework where absolutely everything is a plugin. I want you to picture a giant Lego baseplate. You can endlessly attach, detach, and reorganize the little bricks safely, right? Nothing is permanently hard-coded or glued to the core. And that's exactly why DeepSeek Harness is so incredibly modular. It's built from the ground up to encourage the community to just snap in and openly modify their own custom tools. Now, what's really interesting here is how they actually pull this off. They adapted two incredibly heavy mathematical concepts from type theory and brought them into AI agent runtimes. First up, revertible effects, which handles time composability. This basically dictates that every single modification to the context has to have an explicit inverse function, an undo button basically. Second, reactive coeffects, which handles space composability. This allows the runtime environment to automatically resolve all dependencies on its own. Section 3. Mastering time and space. Let's look at time composability first. Think of this like one of those spring-loaded stacks of plates you see at a cafeteria. Step 1, a plugin loads and makes a change to the system state. Step 2, the system immediately records the reverse function for that change, like putting a new plate right on top of the stack. Then when step 3 happens and an unload is requested, we go straight to step 4. The system executes the undo chain backwards. Last in, first out. It pulls the plates off the stack in the exact reverse order. Because of this, the system perfectly restores itself to the prior state, leaving absolutely zero garbage data behind. Moving on to the space dimension, this operates through reactive coeffects. Instead of developers pulling their hair out writing complex patch logic to check if a database or a chat adapter is running, plugins just explicitly declare what they need. That's it. The system acts as this ultimate omniscient manager. It only auto-activates a plugin when all of its specific dependencies are met. And crucially, if a dependency drops offline unexpectedly, the system safely auto-deactivates the plugin. This completely eliminates those nightmare circular dependencies and startup crashes. Plus, the best part, it requires zero manual topology coding from developers. It just works. Section 4. Inside DeepSeek Harness. For all the developers tuning in, here is how this actually grounds into reality. Looking at the code structure, you can see how the Cortis tree maps core capabilities straight to context keys. Everything is a plugin, contributing to a shared pool. The session log maps directly to ctx.sessions. The tool registry goes to ctx.tools. Even the large language model adapter itself just maps to ctx.llm. Structurally speaking, a running DeepSeek harness is basically a plugin tree made of ordered layers that load up at boot. You have profiles that store the specific bundles being stacked together, and those bundles are what actually distribute the Cortis configurations. And because of that Lego baseplate design, whatever a bundle inserts is always dynamically patchable by the layers sitting right above it. You never have to tear apart the core code just to change how the system behaves. So the absolutely crucial point here, and this is a profound architectural rule written right in their documentation, is model visible means logged. If we want a self-evolving AI, it needs perfect memory. Anything the AI model sees or touches has to be perfectly reconstructible from an append-only session event log. If it isn't in the log, it essentially didn't happen in the model's universe. This naturally leads to an unbelievable level of flexibility through what they call capability seams. Swapping out a service provider changes what the entire product can do, effortlessly. You want to add a new LLM provider? Easy, just register it on ctex.llm. Need the AI to run shell commands? Register a ctex.shell backend. Need it to access local files? Register a ctex.fs provider. You can even patch in human override commands. You are literally just swapping Lego bricks on the baseplate while the system is running. Section 5, the self-evolving AI era. Now, you might be wondering, is this just some theoretical lab toy? Absolutely not. This specific Cortis design has been relentlessly battle-tested in actual production environments for 4 years. It earned its stripes in the wild, powering the Koishi chatbot framework. And during that time, this exact time and space architecture successfully managed over 4,000 independent community plugins, entirely dynamically. That's thousands of different developers writing overlapping, conflicting tools, and the system handled the dependencies and live swapping without a single crash. And this brilliantly illustrates how real technological breakthroughs actually happen, right? They rarely just pop out of nowhere. Back in 2023, a developer named Yifan Shi wrote a design doc called Reversible Plugin System for that Koshi project. It quietly iterated in the open source trenches for years, then, boom, 2026 hits, and DeepSeek, along with Peking University, mathematically formalized the whole thing, dropping this massive 88-page Cortis paper alongside the official release of DeepSeek Harness. And honestly, the success of this framework makes perfect sense when you look at the absolute engineering dream team behind it. You've got Yifan Shi bringing that raw open source grit from creating Koshi straight into the academic rigor of Peking University and DeepSeek. You've got Professor Wei Zhang adding decades of heavy software engineering theory. And you have Tianyi Tui, the harness lead, dropping elite industrial engineering power as a 9-year Jane Street veteran and a 6-time ACM gold medalist. It is literally a perfect storm of engineering talent. Which leaves us with this final thought to ponder. We now have a mathematically sound, wildly production-tested baseplate. When an AI agent is finally empowered to write, install, and uninstall its own tools dynamically without ever losing its memory or crashing the whole system, what will it build next? The bottleneck of the restart is finally gone. The era of truly self-evolving AI might just be starting right here, right now. Thanks so much for joining me on this explainer, and keep learning.